Hello fans of the powerful and widely used Python programming language. Thank you for being with me in another Python tutorial video. We go to the discussion of determining the most frequent items in a sequence. For example, we have a sequence such as list, string, or tuple, and we want to count the number of occurrences of the items in it. One solution is to use dictionaries. The keys of this dictionary are the same items, and the value corresponding to each key is the number of occurrences of that item. A more optimal way is to use the same collections module. One of the functions of this module is a counter. Let's import it from collections, import counter. Okay. Let's have a list named W. What is this error? Okay, I had misspelled the counter name. Let's have the list W, which is containing some names like Udemy, for example, Python, for example, Azal, and some nonsenses like these numbers in the format of strings, and we want to have these repeated. Okay. Okay. And now we want to repeat this one. Okay. Another one, for example. And then, for example, something like these. For example, let's have this one here. Okay. Now let's create an object, for example, w underscore count as an object of this counter. Okay, again misspelled. We should use the bigger format. Okay, let's show this w count here, and we can see, you can see that we have exactly what we wanted, a dictionary whose keys are the items of the list W, and the values of these keys are the number of occurrences of these items. Sometimes we don't need all members of this dictionary. In these cases, we can take help from existing methods to have, for example, some frequent items in this list. For example, let's define a variable named top2, which is this w count, and the output actually of applying the method most common, or with the input argument 2 on our available object. And now if we show this top2 variable, you can see the result. Okay, we can even find out the number of occurrences of each of these items. For example, we can have this, we can use something like a square bracket notation. Actually, you can see For example, if we want to know the number of occurrences of the ghazal key, you can see the output here. Suppose that we have a W2 like this. For example, W2 is another list containing a Java, C++, again Java, and some floats in the format of strings, again C++, for example, R, again the repeated float, for example now Udemy and Python. Okay. Now we want to count the number of occurrences of each item in this W2 and add these numbers with the wcount dictionary values that we already had. This can be done in different ways. One way is to use the merge option, and another way is to use a for loop. For example, we want to have a for loop, for example, for WO in W2. Do what? Let's have this W count, the WO key. We want to have the value of this key, and we want to increase it 1 unit. Okay, now let's call again this W count. You can see the result. You can see the output. You can see that 1 has been added to the value of each of the keys that were presented in W2, which are actually the number of occurrences of those words in the W list, and the new keys values have been created correctly. The interesting thing is that there are even more optimal solutions. For example, if we have a W3 list containing some words like Java, Python, again Python, or Udemy, okay. Now we want to use the method update. We want to apply this method on our available object wcount, and we want to update it with this W3. Now if we show the wcount, you can see the output here. Okay, you can see that the number of occurrences of common words in both lists are added together. Another interesting feature of these functions is the ability to use mathematical operations. We have a W2 and W3. Suppose we define A and B in this way. For example, if A is equal to counter on this W and B is equal to counter on this W2, for example, and let's at first show this A and this B. Okay. Suppose we want to add the results of these two together. One way is to use the update method, and another way is to use mathematical operations. For example, we can have A plus B. Interestingly, subtraction can also be used. For example, we can have A minus B. The performance of these is better defined in real problems. You can see these more real examples in other courses available in Udemy. I myself have training courses in the field of machine learning, deep learning, and neural networks, which are also accessible through Udemy. In these courses, I have presented very useful examples through which you can learn more and more about the applications of these topics and techniques. The next discussion is to sort a list of dictionaries by a common key. So let's go on Markdown mode. Let's insert a square sign, consider a space, and write the topic. The topic is sorting a list of dictionaries by a common key. Maybe you can make some guesses based on the hints we have had so far. For example, consider the list data as a list of dictionaries, like, for example, F name is, for example, John, and L name is, for example, Smith, and SID, for example, is 1020. Okay, and we want to have 6 dictionaries. So this is the first, and this is the second, the third one, the fourth, the fifth, and the last one. Okay, so let's change them. At this time we want to have Linda instead of John, and for example Johnson instead of Smith, and ID card could be something like this, for example. And this time we can have Andrew instead of John, and Williams, for example, instead of Smith, and the ID card can be 2020, something like this. And we can have, for example, Mary instead of John. We can have Jones instead of Smith, and SID could be, for example, 2022. We can also have James instead of John. We can have Brown instead of Smith, and we can have this. And finally, we want to change the first name to Elizabeth, but change the Smith again, for example, to Brown. Actually, the Smith itself could be, but we want to change it. 2038. Okay, let's have this list. Suppose each dictionary contains the information of a student. Previously, we used sorted and lambda expressions. We have learned to sort this list of dictionaries actually based on specific data. Let's have a variable named, for example, sort by f name, and use this sorted with the input argument this data, and as a key we wanted this lambda as we can use a lambda expression here, and we want to sort it based on f name. Okay, now let's show it, and you can see the output here. You can see that these are sorted based on a first name. Now we want to have another variable, this time sort by L name, F name, and again lambda expression, but here the S is based on what is inside in this tuple. Actually the first one should be last name in order to have a more logical actually name, and we want to have this L name here, and you can show it in the next cell, and you can see the output here. Now we want to introduce you a tool to perform this widely used sorting operation. If you want to do this faster, you can get help from the operators facilities. Let's go to the website docs.python.org. In this website, find the operator and see its uses. Let's check operator. Okay, actually here we want to use this item getter. These are the options available in this operator. Among these we want the item getter. Operator. Okay, we want the operator module. Among these, there is an option which is named item getter. Let's search in other words. Operator item getter. Let's do this search. Okay, we want this one actually. Item getter. Okay, this is what we want. This page is where you can find information about the operator module, and among these options available in this operation operator module, we want the item getter option. Okay, back to Jupyter Lab, and we want to import it from operator import item getter. We can have the same expression here, and instead of this lambda expression, we can use this item getter. Okay, when we run this cell, let's this time show this sort by f name variable, and you can see the output. Actually we can also have the same expression here and sort this list by for example SID, and here we should have the SID, and again we can show the variable here. Actually the same could be done for sorting based on two common member, actually two common keys actually, and here we need an L name at first and the F name as the second input. Again we should show these. This item getter takes an argument that it actually uses as an index for lookup. The reason behind the issue is that the item you give it should be an item that the getItem method can receive it. Let's look at here. Here in the definition of the item getter, the item should be an item which can be used in this getItem method. If you want to know more about it, you can use the information on this page. Another interesting thing about this function is that it can be used to minimize lists containing dictionaries without errors. For example, let's see the mean data. Apply the main function on the data. We get an error because when we apply mean to a list of dictionaries, we must give it a key. So here you can use item getter for mean and max. For example, you can have the mean function using data as an input argument, and you need a key which you can use this item getter here. For example, we want to do this minimization based on SID. Okay, the same could be done for the maximization actually. This way is easier than writing a lambda expression. This discussion ends here, and we go to the discussion of sorting objects without native comparison support. Let's go on markdown mode again, insert a square sign, consider space, and write the topic. Sorting objects without native comparison support. Here we want to use another operator method called attrgetter. Actually, you can see the information here. Okay. Suppose you have a site and your site has a series of users, and these users have different information. We created the user class. We need a method for initialization and also another method for viewing the result. Let's create the class. Class user def init self.uid, for example. Now we want to say self.uid is the same UID, and define another method for representation with input argument as the self. We want to return user format self.uid. Okay, let's see what is the error. Oh, okay, this should be like this. Okay, in string expressions like this, what we write in the format is placed in curly braces. Let's have this u as a list of objects of this class user. Some objects like these with different actually UID. For example, these are not real, actually these are all fakes. For example, 495. Let's see what is this u. Let's apply the sorted on this u, and the key will be a lambda expression and t dot uid. Okay, now we want to use the attribute getter from operator import attribute getter. We can have something like this expression, but here instead of this lambda, we can get help from this attribute gather with the input argument the same UID. what is the okay, this UID maybe should be in the string. Okay, so in this way we can use this operator on the classes that we have defined ourselves. We can also do it for minimization and maximization instead of sorting. We can also use for maximization. Okay. The next discussion is grouping data based on a context, which is very widely used. For example, in the example of the site, you want to group your users based on, for example, the year of membership or the level of activity. Let's have another data, which is a list of dictionaries. For example, M2 is, for example, 120. Price, for example, 9.2. For example, city, New York City, and justice. Let's have, for example, eight dictionaries. These are 4, 5, 6, 7, and 8. Okay. Let's change the values. For example, Los Angeles. Los Angeles. Houston instead of New York City. For example, 100, 7.9, for example, and the city, for example, the same New York City. The square meter, for example, 150. Price, for example, 1.1. And the city, Houston. The square meter, price, for example, 10.1. City, the same New York City. A square meter, for example, 140. Price 7.6. City, for example, Los Angeles. For example 10.1. Okay, let's assume that each of these dictionaries contains information about each house. Now we want to group this data, for example, based on the city. If the data we have is very large, this grouping can be very useful for extracting primary information. At first, we need to import from operator, import again itemgetter, and from tools import group by. Okay, now we want to have data.sort. The second method of using sort or sorting list is using a dot and the sort word actually. And now we need a key, which we want to use itemgetter here, and we want to use this action based on city. Now, okay, missing a parenthesis. Okay, now we want to show this data. You can see that this list is now sorted based on the city, which is alphabetical sorting actually. We can group this list actually. Group by returns two things at you. We can have a for loop here for city and item in group by data key is equal to itemgetter, and based on city key we want to print this city, and for I in item we want to print. At first you can consider a space in order to have more more regular actually output, and then you can print this I. You can see that this space is applied here. Okay. In fact, one of these two group by outputs in the key based on which the grouping is done, and the other is the generality that is included in that group. Another type of grouping is to store data within a larger data structure in the form of a group of groups. So what was our data? Okay, this is our sorted data actually. Now let's import from collections the default dict. Okay, now let's have a variable named for example data by city. We want to get help from this default dict, and we want to apply it on a list. Now we want to say for R in data this data by city. These are, we want to value of the value which is corresponding with this city. These are in this data by city. Okay, and then we need to add this R, so we need to use the append. Okay, for example, we can do the same, or we can have a 4. Actually, we can do it separately for R in data by city, the value corresponding to the key New York City. Print these are. You can see the output here, and we can actually have the same for Los Angeles. And I have the same for Houston. Okay. This solution is faster because it does not require initial data sorting, but choosing the optimal solution depends on the conditions and purpose. Thank you for being with me in another educational video of this fascinating programming language. Stay tuned, very useful tips are waiting for you in future videos. Have a nice day.